for the introduction. Nice to have you all here. I can't see any of the faces, but that doesn't matter. I'm Michael. I'm working for a company called Container Solutions. We are a consultancy company helping, customers to be successful in their cloud native journey. What that means, we come to that later. I'm at that company for almost 5 years, and we are almost in existence in 6 years. So almost at the beginning, I'm at the company. And now let's talk about what we are going to talk about. This webinar, the part of myself at least, it's not about what cloud native is in general, and I'm not going to talk about Kubernetes. Franz will dig deeper into what Kubernetes is and the challenges with it and how Giantswarm will help with that challenges. I will talk about why you should do cloud native, how a typical journey looks like, and how to do better adapting our processes, and of course, different operating models of such platforms or cloud native things, not just platforms. Why cloud native? It can be as simple as this. It's about creating value at speed, because time to value and time to market matters. It's about reacting to customer demands and changing customers' demand. So by adopting cloud native and cloud native technologies, they are distinct things, you will be able to deliver customer value at any point in time as fast and as safely as you want to, as you urge to do. The distinct between cloud native and cloud native technology is cloud native technology is basically everything you find on the CNCF landscape, and cloud native in itself is everything from culture to tech. So it entails a bit more, and I'm going to talk about cloud native, not cloud native tech. Why should you adopt? This is still, why should you do it? Basically, you need to be able to also react to the certain circumstances, like challenges are coming. Each industry basically in existence can at any point in time be disrupted. They are called challenges. No one would have thought in the taxi or hotel industry or even finance now that they are threatened by startups, but they are the Ubers, Airbnbs, Monzos, Starling banks are coming, and they're coming fast. If you are not able to react, to change, and to adapt fast to then also changing market demands, you might be at a certain point out of business. Cloud native can help with that. It enables you to change things at any point in time, safely, react to changes, using technology which is in existence, and then of course operate them. How does a usual adoption look like? So we all have seen, well, we should adopt it. It makes sense. It allows us to do all the things we ever wanted to do. Let's say that's even true. Usually adoption looks like this. Let's call her Jenny. Jenny is a head of engineering, head of IT, head of development, whatever, a middle manager who is responsible for the tech part of your business. And she realizes we must do something in order to be able to change things faster, more reliable, take in customer feedback, a lot of things we want to do. She thinks we can do this with cloud native, so let's get cloud native. What she does is like, she gets approval from the CEO, budget, time, whatever. She creates a backlog. This is of course not a complete backlog for cloud native journey, but let's assume certain points of this on a really high level need to happen one way or the other. And then it's put in the backlog, and then the engineering team goes on and starts working on it. 6 to 12 months later, the date runs by, budget is gone, nothing has been delivered. Most of the cases is because, of course, the legacy system needs still love. You still develop new features. maintenance. A lot of things need still to happen on your legacy code base, on your legacy infrastructure, because you need still to serve your customer, and you still need to deliver new features to create more value, more revenue, all of that. So nothing has basically happened. You might have set up a cloud account, worked maybe or maybe not even on the cloud governance, but nothing is running on that infrastructure really. Of course, then let's try it again, get another approval. Let's work on this. Jenny did read about something called bimodal IT or two-speed IT. Gartner and McKinsey promoted it a couple of years back quite prominently as the solution to transformation, to turn a legacy or old-fashioned waterfall organization in more agile ones. The idea was you split up your delivery teams in a legacy old fart group and a hipster new stream thing, and at a certain point they might merge together and all are now hipsters wearing skinny jeans. That never was holding true. Even Gartner and McKinsey don't promote it anymore and even publicly announce that it's even a bad idea because basically it doesn't work that way. But she thought it sounds appealing, it might work for her, so let's still do this. Another 6 to 12 months later, more or less the same outcome. Nothing, basically, nothing has been migrated really, or maybe a small portion, but doesn't matter, it's too little to make a difference. But on the other side, it had an impact on the company because by splitting up the team, you decrease the delivery of value to your customers because basically less people are working on new features, improvement, stability, all of that. So it might have even had a negative financial impact to you. Then the CEO gets a bit upset and basically says, you need to get this done, maybe in less friendly words, but that's basically an ultimatum she gets. So again, she needs to do something, and that's where Transform and Container Solutions come into play. She basically reached out for help. We developed over the course of the almost 6 years in existing holistic process on how to map out that journey and how to make them successful. When we come, we usually do an assessment. So we look at all axes of an organization. Which ones? I will come to that on the next slide, but we will look into culture, processes, and technology, tech stack, delivery process, everything. The easiest way to understand that it's not about just about installing Kubernetes and maybe some issue on it. It's a transformation. You need to change usually as well the way you are doing this, and the easiest way to accept that change is coming is just assume everything is wrong, even though in most cases it's not the case. A lot of the things are already right and properly set up, but mentally it's the easiest. If you assume everything is wrong, then you ask, how can you improve? And then you lay basically by these lines of thought the ground for a proper transformation. Then we come and use this as a guiding principle, our container solutions maturity matrix. You want to get cloud native, we do an assessment, then we define this basically where you are, and then do a gap analysis and lay out what needs to happen in order to move you from where you are to cloud native. The whole process of this is our delivery process, which we call think, design, build, run. The think phase is basically the assessment where we, at the end, deliver multiple results. One of them is the maturity matrix, and then a detailed report on what needs to happen. Then we go into the design phase where we plan the architecture, do POCs on things which we need to prove right or wrong. So assumptions which we've made, but things are sometimes specific in specific context and need to be proven right or wrong. If wrong, we need to have a new idea and prove them right or wrong, so on and so forth. We do this all using agile practices, but also we start already in the design phase with training of your people. A transformation only happens if you change the way you are doing things, and you only change your thinking when you change the way you work. And you should start with training, then you change what you basically have done so far and doing it differently, and after 12 to 18 months, you basically then your thinking follows. After the design phase, we go into the build phase. Build phase is when real execution happens. We build an MVP platform, we build the production systems, educational program, onboarding, all kind of different things, migration of your legacy application to microservices and onboarding of the system. And then out of the build phase, then we go into the run phase. The run phase is basically we offer for what we have done basically as well 24/7. This works best, of course, when we work together with, for example, Transform. We know each other since company existence, and we have done the whole process now multiple times at multiple customers, but namely 2 of them are big companies like GK Software and Adidas, where we have worked over years successfully helping them basically transform from wherever they have been to a real cloud native company or build a cloud native platform and operate them. Over the course of time, your effort needs to go towards cloud native, and your legacy effort should go to almost 0 or 0. Applying our proven process, it kind of looks like this. So the time span usually till MVP kind of production is 3 to 6 months. To become fully cloud native, that's an ongoing process. With or without us, but things will never be finished. You need to iterate, and to become cloud native, it's a journey of 1 year till 3 years, something like this. Then you have built a cloud native system, and then you realize you need to operate that. It's not different from DevOps. Usually you have a 2-pizza DevOps team. What that means is a DevOps team should be small and efficient, and Werner Vogel, I think, coined the 2-pizza team, which means you should be able to feed the team with 2 pizzas of normal size. So basically 5 to 7 people. A team of 5 to 7 people can't really operate 24/7. Why? Basically, math is easy. Assume you have a 5-people team. It would mean that each team member would be on call almost every second week. The main problem is not just holding the pager, but things will happen. There are events, there are incidents, so people need to get up or will be interrupted during the day. If they get up in the night, they might not be at their best self the next day, so issues will be happening because they can't concentrate that well. A lot of things might lead to less quality and more incidents, and not proper sleep is one of them. And the other one, if they build what they've run what they've built, they also will be interrupted during the day when they focus on new features, improvements, things like this, and lose their train of thought to handling incidents. So it's an ineffective thing. Before I talk about the solution, I want to clarify some terms. And one of them is, of course, DevOps. That's more known, often coins as well. You build it, you run it. So YIPRI, they are small effective teams, as we have just learned, 5 to 7 people. Usually they build and operate their own applications and infrastructure parts. Dependencies to other teams are managed via APIs and API contracts, usually applying agile methods. The new, it's not new, but it's more common, or it's trending at the moment, is site reliability engineering. these guys offer support for services of the delivery team. Which kind of service doesn't matter. Can be application, can be infrastructure, can be both. It's basically your 24/7. But it's not the typical third level operations or first, second, third level. The ops work must account for less than 50%. They only accept services or infrastructure if they follow a certain architecture. They need to be stable, and this will be proven in the production readiness review. And only if they pass this and work on the findings, they basically take the 24/7, but everything is still shared. Shared monitoring, shared paging, so the product team still gets notified about quality. Error batches will be agreed on, service level objectives, all of that. One powerful thing is that if over time the quality decreases, SAE team can hand back the pager and say, well, stop deploying, fix first stability, then we are able to then again do the 24/7 for you. Of course, SAEs can be part of a team for a certain amount of time to help fixing issues. Side by side, looking at the two team setups, it's like the DevOps team is a delivery team. Usually you have cross-functional people like T-shape, typical T-shape, deep knowledge in one area, but should be able to do a slightly left and right. Usually focus on end customer projects. You build it to run it. So what they build, they need to operate. The automation is purely focused on delivery. The KPIs are usually business metrics, conversion rates, more views, response time, a lot of things which are more business rather than pure tech. They are optimized for lead time and value delivery and tend to do more than 80% dev work and usually do Scrum. On the other side, you have SAE. It's an engineering team with infrastructure focus or reliability focus on infra and applications. They tend to have more engineering project. It doesn't need to be platform because it's not entirely focused on infra, but if they focus on application, it's also still engineering, and it's performance engineering and things like this. They run infra and maybe your apps, depending on the setup. Their automation is focused on operability. Their KPIs are typically service level objectives and error budgets. They optimize for number of pages and operational load. And usually they do 50-50, like 50% engineering and 50% ops, and tend to do Kanban. We offer SAE as a service. We call it customer reliability engineering. Why we do this? Because we believe if you build a system, we are easily able to operate it later. We help to operate large-scale systems in a scalable, reliable, and effective way. We are then part as well in helping you, guiding your architecture, your system architecture. If you plan new things and we are part of it, then we help you guiding towards a stable and reliable and scalable system. We use typical engineering approaches to this, and well, we hope for the best but plan for the worst. We have all the procedures and incident management and all the things in place to help you. We do that best, of course, jointly with, as you can see on the bottom, jointly with Giantswarm. They take care best of the platform, and we can take care of anything else, like the cloud setup, your application. So you can focus, or your DevOps team can then focus on value delivery. How Giantswarm is operating Kubernetes at large scale, well, Franz will now take over and tell you exactly this.
Yeah, thank you very much, Michael, for taking us through the typical journey that people and companies will go through. I'll just share my screen that I can take over a lot easier. And yeah, and actually I want to focus, once you actually kind of, have made all the decisions going cloud native and then, brought your team on board. then figured out what you need to, what technologies you need and so on and so forth, you basically then need to think about day two operations. And day two operations is something that, where you actually then go into production. And from our perspective, it actually makes a lot of sense to think about day two operations really, really early, because if you actually look at things, if you, let's say, start off with a installation, a cloud native stack, or you're by yourself, and then suddenly need to go into production, you might find things that actually don't work. You might need to figure out how to actually really do it in a secure, reliable way. And then you need to figure out how to really set up your production environment and migrate your workloads over. That might not be too much of a problem, because it's only a development environment, and and you can have different systems. But basically, the challenge that most companies run into is that they then transfer that development environment into production, and that's where they then basically see, oh, well, we actually need to make changes, and making these changes in production is really, really hurtful. So actually, I would like to take you through the journey of what you need to consider in terms of day two operations and of such a cloud native stack, and then basically you can actually get set up, prepared very early, and then take on this journey very proactively. So to see if that works, let's take a quick look at the cloud native environment. So basically, when you set up a platform to develop your applications on top of them, you basically get rid of lots of elements that you used to have in your applications and abstract them away into an infrastructure layer. That complexity doesn't go away, it just moves on to a different layer, and someone else needs to take care of it, because as a team, you're too small to take care of the whole infrastructure. You basically need to focus on your digital product. And the way it actually is set up typically is you've got your physical layer of servers, and that can be either in the public cloud, AWS or Azure or whatever, and then your data center is another option if you actually want to run everything in-house on-premise. And typically you've got a data center team or the public cloud provider is taking care of that. And then you basically have a virtualization layer on top of that, so you can make better use of the servers and infrastructure that you actually then have. And then on top of that, first of all, you need to prepare that so you can then install your cloud native operating system, which basically predominant is Kubernetes now. There are some like OpenStack and Docker Swarm and whatever other technologies out there that basically have looked quite competitive, but in the last couple of years, basically Kubernetes has outperformed them by far in terms of community, in terms of evolution, in terms of performance. So yeah, that's probably less of a question now than it used to be. And you actually need to get your environment set up so you can install Kubernetes. That's your orchestration engine. And then you spin up different clusters for your development environment, staging environment, production environment, for your different projects, and so on and so forth. So then you basically have these different clusters, and there you install your containers, and you prepare the containers naturally with the operating system, whenever you package everything. And then you install maybe apps on top of that that then take care and handle different tasks for your microservice, be it Kafka or something else that basically then already takes over a lot of functionality that you don't have to develop all by yourself anymore. And on the right-hand side, so basically that's the kind of the generic structure. And then on the right-hand side, basically, I kind of sketched out the responsibilities. As I said, on the lower end, it's the data center or the cloud native cloud provider, and then at the very top, you typically have your project team or platform team taking care of elements in that space. And in between, you need to figure out if you do it yourself or if you actually use someone like Giant Swarm to do it. But basically, there are lots of components in there where you need to make sure that, for example, you address security. You make sure that everything's secure from virtualization all the way up through the orchestration engine and clusters into your applications. You need to make sure that you are that you set it up very reliably. So you basically spin up sufficient nodes and make sure that you have the workload distributed, that it can the connections, the APIs and gateways actually can handle the load. So you actually can really run your application in a very reliable environment. And then you naturally need to set up monitoring because you want to know if something's going down or going south, or if even preventive. So you actually want to know if certain thresholds are reached, so you can then basically take preventive actions and make sure that you actually take care of things before shit hits the fan. So and once actually really something happens, or something really goes down, you need to naturally restore it. That's less of an issue, but it's actually more the issue of solution. So figuring out why it actually went south, and really figuring out how to fix it permanently. Because what you actually don't want is having an emergency every morning at 8 o'clock when the developers actually want to start working, and then basically the system goes down or something. The production environment needs management to then basically restore operations. So what you then need to do is you need to isolate the issue. You need to figure out what the root cause is, and that can go all the way down to your cloud provider or your data center. And because you actually basically only identify the symptoms and not the root cause. So that can take a lot of time, but necessarily needs to be done. And we actually typically, just to give you an idea that these things happen, we operate naturally for many different customers, but we typically spend about 500 to 600 times a year days of effort in terms of root cause analysis. We call that post-mortem analysis. So 500 to 600 post-mortem analysis that can take anything from an hour to several days. And then basically we actually make sure that naturally all our customers get the fixes, so we don't run into any issue that we already identified with one customer with another customer. You will have to do that over and over again for yourself if you operate that yourself and have your custom stack. And then you need to think about evolution. So there are changes, there are always changes to different use cases that might require different technologies. There are new versions out that, with deprecated APIs or something like that. There are end of life projects, like, for example, the Core OS replacement with Flatcar, for example. So where you've got an end of life and you need to make sure that this migration happens. And then you also need to think about enablement. Think about how you can empower your teams to make most use out of the platform. So they basically don't set up things in a way, or don't develop applications in a way that impede the environment, or don't even make use of it properly. So if you actually look at, for example, spot instances, you can actually save about 80% of the cost of your workload or the consumption of your public cloud provider. But if you actually don't build up your application so it can breathe, and really use the resources, and then you basically have other machines that become available that are cheaper, and then they actually are turned off and switched, and your workloads need to move. That's where typically you actually can't make use out of all the functionality that is out there that can help you save a lot of money, and can also help you really drive performance for your environment by spreading your workload across a larger number of machines. So there are actually different aspects you need to take care of, and you can naturally do everything yourself. I'm pretty sure there are actually competent people out there, but in many cases that's actually a journey, as Michael already showed, and a journey of many failures. That's how basically all of us learned, and that's where we basically see a lot of value, working very, very closely together with customers, because they've got many questions, and we make ourselves available very easily through Slack channel constantly. So they just type in a question and get an answer, and then that's how they can move off and move forward, and that's how they can accelerate their journey. So basically, that's basically the setup of the cloud native environment. But what I actually also wanted to highlight is that, as you can see, this is not only about technology. I know there are many discussions around Kubernetes happening purely out of a technology perspective, but you also need to consider the operations perspective, which is in many cases just assumed as a given. You install Kubernetes and it runs. You don't have to worry. It's like you install it, yeah, you need to set it up, but then basically you don't have to take care of it too much, which, to be honest, isn't the reality. And just to give you an example, Shutterstock, for example, a company that I would consider, really digital native, and really, started off with container orchestration from the very, very beginning, is a company that actually ran Kubernetes 2 years all by themselves, and they actually switched to us about a year ago. Because they said it's just getting too much and it's taking too much of their time and focus. It's distracting them too much. So they're actually now leaving the operations up to us, so they can then focus on really building their product and their digital product and acquiring naturally market share and driving revenue. So there are aspects that you might not perceive from the very beginning, but they actually will feel them on the journey. And I think that's also something that Michael pointed out, which is something that you actually need to anticipate, that you actually will have some pain points that you need to handle, and depending on how fast you want to move and how critical an application is, it actually may make sense to really team up and figure out how someone can help you in that journey. So if you actually look at more technology-oriented companies, then they typically talk about Kubernetes and different, let's say, the different apps that you can install on top of that, and the cloud native stack and certain functionality, but they actually leave operations out of the game. I personally think operations is actually the most important part, because the technology impacts operations and operations also impacts technology. So that's where you basically need to keep a balance. And when you keep a balance, that's where you basically then can really take the smartest decisions for you going forward and make sure that you actually can have a great continuation of your stack and the evolution of your stack. So just take automation, for example. So yes, you actually can do everything manually, and that's what's provided as a managed service, and often by large consulting companies, that basically then outsource operations of Kubernetes to low-cost countries. Yes, that's nothing wrong with that. It might turn out to be cheaper for you, but basically what you need to consider is that you actually will have to do these things over and over again, either you or your service company or someone else. And that's why we actually focused lots of energy, because we already knew we will have to do that for many companies. We basically focused, like from the very beginning, 2014, when we were founded, we actually focused all our energy on automation, building operators, making sure that anything we identified that we could automate will be automated, because it will actually help us make our service a lot more efficient and actually more successful for our customers. And if you actually don't invest the time in automation, that's where you will feel it in operations, because then you need to put manpower in there to basically handle configurations and checkups and everything. And that's a very great way of really seeing how both of the areas impact each other. Another thing is, like, for example, upgrades. If you don't run upgrades, you actually can decide not to do it. Then at the end, I think Kubernetes is supported for the last 3 versions. That's typically, they actually issue a new version every quarter. So that's, like, let's say up to a year. And that then basically means that, after that, you need to pay a lot for support from an organization that will help you fix things in an old version. So if you can actually choose to to upgrade a lot and feel the pain in the beginning, but then make that very smooth process, or you can make sure that you basically, that you actually put the money aside and pay for contracts for someone to support you in an old version. And to be honest, you actually will have to rewrite your application at some stage just to make it work with the newer versions, and that actually can be kind of something you need to consider also going forward in your decisions on where you put your effort. Same for multi-cloud. If you actually, decide to go with AWS and then you want to do something on premise, you typically have two different stacks, unless you have a distribution that supports both. And then, you actually have two different teams. You have different focus areas. It's even worse in many companies that actually don't decide to go on a central platform, that they then shift the management of the Kubernetes into the teams. So they've got each individual team taking care of the part of the cloud native stack that they need to operate, which is a lot of wasted resources. So that actually also impacts operations and also speed in terms of time to market and agility in terms of delivering functionality that your customers request. And naturally, if you actually have a look at Kubernetes and the evolution, there's lots of things happening. It actually makes sense to really work with upstream versions that actually provide you with as little lock-in as possible. So basically you can switch anytime because there will always be changes in a community that is so big and vast, like the Kubernetes CNCF community, that you basically, we need to be prepared to make changes. And the more you use technology from a single vendor, the more and rely on that, like a public cloud provider, then you actually will end up having to either stick with that solution and get really well at it, or be really sure that they will be the ones that actually will come with the most innovation the fastest, or you build it and use components that actually are open source and upstream. So you basically have a community that supports you, and then you can evolve very, very easily. On the operations side, you basically need to make sure, as Michael pointed out, to manage 24/7, and that's not only for your application. It also means the infrastructure, the Kubernetes infrastructure underneath, and typically you actually don't have much overlap. So the people that actually need to know their stuff with Kubernetes and the environment is actually, it's a very different skill set that you actually need to, and knowledge you need to cover. So that's actually, quite challenging. There's also a constant learning curve. There are new technologies, new functionality, there are new ways of doing things. There are lots of lessons learned, and you actually need to be sharing that. You need to build up a team. That's why we basically, team up our solution engineers with a single customer, so they basically can then interact very, very closely. We actually have this, we don't have support tickets. You just ask questions in the Slack channel and get the help immediately, because anything else just doesn't work in terms of you having the greatest speed in terms of developing your functionality. You actually don't want to waste any time looking at functionality or figuring out issues and looking for resolutions. You actually just want to problem solve. And typically Kubernetes is not the problem you want to solve. You actually want to enable your application to do whatever you want to do. And then naturally you need to constantly evolve and tighten the setup and do root cause analysis, as I mentioned before. So these are the areas you basically need to cover and think about from the very beginning on how you want to cover them, and then you can actually make decisions. And I actually want to walk you through a little bit of the technology side now, and then we actually look at the life cycle. So you have an idea of what are the aspects you might need to cover. We actually had a webinar last week where our platform architect basically came up with this Kubernetes is a beast, and I actually kind of agree, because Kubernetes it's it's basically it's not Kubernetes only. You've got etcd as a database, then you actually have the monitoring, the logging, tracing, then you need to access OSCDs, then you actually need access rules, you need ingress, incoming traffic, then you need the scheduling, setup scheduling, alerting, so you actually can then notify. So there are many elements around Kubernetes that you actually need to take care of. I just spoke to a customer last week who's actually set up that everything themselves. Interesting enough, around EKS. So they basically got that from the cloud provider, but they actually built a set of 40 components around it that actually then basically helps them manage Kubernetes, and no wonder, they actually basically feel quite fed up by it. So that's why we're talking, and that actually is like, you can see this green pod area in the middle. That's where your application, your microservice runs. That's where basically you really make a difference to your company. So everything around it is just like, yeah, you need it, but it's not the differentiating element. And I think that's, it shows very nicely of what things you need to consider when you actually go into the Kubernetes space. The second aspect is, as I said, like, the two operations. So you need to take care of installation, securing everything, managing 24/7, monitoring 24/7, fixing it and upgrading it. And I actually want to take you through each of the stages so you have an idea of what I'm talking about, and it's more tangible than if I just talk about it in general. So if you actually look at installation, you actually can, then you need to start off with segmenting and configuring. So, it depends on how you want to, first of all, what applications do I want to bring to cloud native? How do I want to segment them into different groups? Do I want to have a cluster for each application, which very likely doesn't make sense because you actually will easily over provision. Then you want to group them together. You want to segment your network. You want to make sure that you configure Kubernetes in a way that actually helps you execute the way you want, have different teams, take care of different elements, make sure that you provide certain services and components to different teams. So really make sure that you actually have a good idea of what the setup, the initial setup needs to be, and and you actually, if you don't understand the picture and what needs to happen, you will typically end up having to redo the installation over and over again. And at some stage, you might just set up it newly and just migrate your workloads over if something fades. But that's why you need to just think about this at the very beginning. Another element is naturally you've got the upstream Kubernetes version, so you need to install that. You need to make sure that you basically also have the components, like the core components, like networking and ingress, OSDC, so authentication and certificates in there. That's something you need to have covered. Then you need additional apps. If you've got APIs, special API requirements, you may want Kong, or you go with service meshes like Istio and Linkerd, where you actually basically can create lots of activities and all kinds of configurations that you need to try in different environments. And at the end, you might find out it actually isn't the tool you're looking for. It's a certain use case. Let's say canary deployments. You actually want to do canary deployments. You install Istio for that. It's just a total overkill. So it depends on the use case you want to do. So figure out what the use case is. Take your teams through that discussion so they actually have a clear understanding what the use case is, what they want to do, and then figure out what application you want, and then install that application. And then configure it and manage it and so on and so forth. So there are many elements that you need to take care of in the installation phase that can actually really make a big difference on how easy it is to operate. And actually the automation aspect, yes, you can actually get a Terraform and whatever and build your automation scripts and whatever, but how do you make sure once it's actually set up that it stays set up, that it actually checks this constantly, that it actually pulls up new instances over and over again, that it actually notifies you. There are many aspects you basically need to build around it that already are covered through quite good automation that doesn't require you to do it yourself. So think about installation in terms of all the different tasks. It's not just simply installing Kubernetes and hit run. The other aspect is, it's the second step, is think about security. Every company actually has their own security concept. Typically, it's not a cloud native ready security concept. So actually, with every customer, we go into that discussion with the security team, because the core requirements were more like, let's lock everything down, make sure that nothing can happen. The cloud native paradigm is actually, let's make everything possible, let the teams do whatever they can, and control everything in Kubernetes, for example, like pod security policies and role-based access and so on and so forth. So there are elements that you actually can, where the security concepts needs to change, and where you might need to install additional apps that take care of security, like the scanning of the containers and so on, like Aqua and your Vector and so on, that you might then need to install in addition. And you naturally need to constantly revise their security patches constantly, where you need to make sure that the security patches are applied, that your team needs access to something different, so you need to you might need to open that, or they actually don't need access anymore, so you might lock it down. So there are many, it's a constantly evolving setup, and we typically do that like on a weekly, monthly basis. We discuss that with our customers, and how we can change the setup. So the security department is happy, but also the teams are very flexible in doing whatever they want. And then you've got the management aspect. So you need to configure components. As I said, the changes depending on your applications, what you're actually trying to do, is something that that basically changes, and you need to adapt to that. Provision your clusters, whatever it is that you want to do, and then you actually need to identify once there is a new version available. For example, what are there breaking changes? Are there anything that impacts the applications you actually have on top that you may need to consider, or the teams need to consider? And they need to get ready, or the application ready, so you can upgrade very easily. You need to plan these upgrades. There might be different applications on the same cluster that move at a different time. So that's where you actually need to figure out how can you encourage the teams and segment also the clusters appropriately, so you actually don't keep anyone behind just because someone else can't move fast enough, which actually used to be a very big problem with the one cluster and two cluster setups that most vendors actually delivered. We decided from the very beginning to go multi-cluster. We actually have customers with 50, 60, 70 clusters. Yeah, that's something that we basically designed our product and the automation around it for multi-cluster setup and operations. And you also need to empower your teams on, as I said, like the breathing of the applications and how it can impact, how you can create failover architectures, how you can make sure that that the applications are, and the services are capable of just going down and just being restarted and pick up their work from there. So that's where you as a platform team, if you've got one in your company, or as the person responsible for Kubernetes, need to figure out how you can empower your team understand. And with Adidas, as Mike already mentioned, basically container solutions came in and basically took them through the whole process and made empowered them really to understand and appreciate how to do this cloud native journey. And now the platform teams, they actually go around and train the internal teams in addition, just to make sure that they actually build the applications as cloud native as possible. And then we've got three final steps. Speed up a bit. Monitoring, yeah, you actually need to set up monitoring because you actually want to know upfront if there's something going wrong, if there's certain thresholds, so you actually know before it goes wrong, and then naturally the alerting and tracing, so you can then fix it. you need to think of 24/7 shifts. So that's at least 6 people. I think Michael already introduced you to the concept of how much resources, how many resources, and how much time you actually need to associate how many people. So they actually aren't bogged down by these shifts constantly. And yeah, then you need to have support contracts in place in case your team actually doesn't know what to do, and they actually need to figure out how they actually can move the problem away. So basically, that's in terms of monitoring and fixing things, that's something you need to consider. And also, the time it takes to isolate issues and then report that. And typically, if you've got an old support system, then you will set up a ticket and you will get questions like beginner questions over and over again. After 3 days, you basically get to the right person to talk to where you can figure out a problem. So that actually can be quite tedious. And that's why we established, for example, direct relationships to the different teams at Microsoft and AWS and so on, because we actually circumvent that. Because we actually don't need to explain the problems over and over again with the experts we actually have. And yeah, and then once you actually have identified the fixes, you need to deploy that individually to each cluster, or you've got some kind of automation. We actually built that into our automation. And you also, and that's something really helpful, consider automation also for your configuration, because you can't believe how many problems we actually see is because someone on the customer end actually changed their configuration and now it doesn't work anymore, and things haven't changed, but it's still failing, and then we figure out, okay, that's the root cause analysis. So configuration actually is something a big pain for the Kubernetes operations. And then upgrade. We've got new releases every 3 months, major releases, to be honest. All basically many bugs get fixed in new versions. So if you don't want to run into any issues, you need to upgrade. Get that upgrade process really very stable, very fast, very easy, very painless. And yeah, and also think about upgrading your apps. So you actually might have that stack of 40 applications, as I said, by that other customer that then basically need to be upgraded independently. So how do you do that? How do you manage? How do you make sure that you know what version runs on what cluster? If you actually have deployments, then it might fail in one or even fail in production. So that's something you really need to get a hand on. That's why we actually developed the app platform to manage that automatically. And yeah, you actually also need to help the dev teams get their application prepared for the upgrade, and also have the upgrade mechanism, so you actually have got rolling nodes and everything, making sure that you actually have upgrades with zero downtime. So with that being said, I actually hope I could picture, all the things you need to consider, all the aspects you need to consider. Hope I could provide you with some guidance on terms of what you need to take care of, what you need to think about from the very start, so you can set up your team as effectively as possible, or naturally you can get container solutions for the cloud native journey on us for operations. That actually goes hand in hand. So you actually know that it's a very smooth journey. You can actually basically make sure that you can focus fully on delivering your digital products. And yeah, as a summary, think about if you need Kubernetes. If you need Kubernetes, it's actually an investment. So that's something don't think it's just install and hit and run. Think of the cultural change. Also focus on how to deliver fast. As Michael said at the beginning, don't waste the time, going through the learning curve and not delivering. Think about what exactly you can deliver in what time frame and focus on that. And when you choose Kubernetes, always think about technology, operations, and the cultural change. So you actually, and the best setup for that, so you can then deliver the biggest value and make sure that your teams deliver the biggest value in the shortest period of time. I think there's a lot of opportunity out there, and yeah, and if you actually do it right, I think you actually have a right set on how to proceed and how to succeed. So with that said, yeah, I actually will open for questions, and we'll address them.